Okay, for lesson 4.5, we will define the trigonometric ratios. To define trigonometric ratios, we will be using the opposite side, the adjacent side, and the hypotenuse. So there are three trigonometric ratios here. The first one is sine, and it is abbreviated by SIN. The second one is cosine, and it is abbreviated by COS. And the third one is tangent, or TAN. Okay, so for the sine ratio, we get the ratio of opposite side over hypotenuse. So since we're talking about sine B here, B, the letter inside the parentheses, that is the angle of interest, okay? So we want to find sine B, cosine B, and tangent B. So for sine B, we want to identify or get the ratio of the opposite side of B and the hypotenuse. And that is your SOH. Okay? So sine, that's your S, equals opposite over hypotenuse. Then for cosine B, we want to get the ratio of the side adjacent to B and the hypotenuse. So that's your CAH, cosine adjacent over hypotenuse. And the third trigonometric ratio, is the tangent. So tangent of B is equal to the side opposite of B divided by the side adjacent to B. Okay? So that is your T for tangent, O for opposite, A for adjacent. So to remember this trigonometric ratio and what sides we use to get this ratio, just remember SOHCAHTOA. S is for sine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Let's take a look at this example. So we're given this triangle with sides 3, 4, and 5. Okay? First, let's identify the opposite, adjacent, and hypotenuse. Now, the angle that we are interested in here, okay, is K. So here is your angle K. Now, we know that the hypotenuse is the side across from the right angle. Here is the right angle. Across from the right angle, that's our H. The side across from K, the angle across from K, that's the opposite. And the side next to K is the adjacent side. So remember, sine is opposite over hypotenuse. So we're looking at the opposite side and the hypotenuse. The O, the opposite side, is 4, and the hypotenuse, the H, is 5. Now for cosine, cosine is the ka. Means we want the adjacent over the hypotenuse. So the A, the adjacent side, is 3, and the hypotenuse, the H, is 5. Then for tangent, we have the TOA, okay, opposite and adjacent. So the opposite side is 4, and the adjacent side is 3. Okay, you can stop this video and try working on the next one. So if you have finished, check your answers here. We want to find the ratio that represents cosine A. So we just want cosine A. The angle in question here is A. Here is our A. That's the angle. Okay. Now for cosine, we use ka, meaning adjacent over hypotenuse. But before we do that, let us first identify the sides. Okay, so here is our right angle at C. Across from C, this is our hypotenuse. Across from A, that's the opposite side. And next to A, that is the adjacent side. So for cosine, cosine A. Cosine A is equal to the adjacent side, which in this case is 5, over the hypotenuse, which is 13. Okay, example number 2. Write the ratio that represents sine P. So P is our angle. Let's identify the parts. Here is the right angle. 10 is the hypotenuse. Across from P is the opposite. And next to P is the adjacent. Now we want to find sine P. Now sine, that's your SOH. So that means we need the opposite side and the hypotenuse. So sine P is equal to O. O is equal to 6 over H. H is equal to 10. There's no need to simplify. That would be fine. Example number 3. Again, pause the video and work on this by yourself and then come back here to check. Number 3, write the ratio that represents tangent C in the given triangle. So the angle in question here is C. Okay, tangent C. In this triangle, across from the right angle, that's the hypotenuse. I'm missing something here. Let me check what's missing here. Okay, this should be 15. Sorry about that. Okay, so 8 is the opposite side, and 15 would be the adjacent side. Okay, so tangent C, for tangent, we use TOA, meaning we use the opposite and the adjacent side. So tangent C is equal to the opposite side, which is 8, over the adjacent side, which is 15. Keep working. All right, number 4. What is sine L, cosine L, and tangent L? Here is our angle L. Okay, so in relation to L, 10 is the hypotenuse. And by the way, class, if you are given 3 sides, you know that the hypotenuse is the longest side. So it has the highest value. So between 6, 8, and 10, 10 is the highest, then that would be your hypotenuse. Okay. Side across from L is the opposite side. And next to L is the adjacent side. Okay, so we want to find sine L, cosine L, and tangent L. Okay, using our acronym. So, KATOA. So, KATOA. All right, so sine L would be O over H. O is 6 and H is 10. Cosine L is A over H. A is 8 and H is 10. And tangent is O over A. O is 6 and A is 8. Need some more? Let's take some more. Okay, so again, pause the video, do this on your own, and then check back. So for this one, we want sine A, cosine A, and tangent A. So we're interested in the A. It's already shaded here. Okay. So in this triangle, let's identify the 3 sides. Across from B, B being the right angle, is the hypotenuse. Across from A is the opposite side, and right next to A, angle A, is the adjacent side. So our acronym again is SOHCAHTOA. So sine A would be O over H. O is 12 and h is 13. Cosine is AH, A is 9, H is 13. And tangent would be opposite and adjacent. So O is 12 and A is 9. Make sure you're getting them all correct. All right. For number 6, we do not have a triangle. So we'll have to draw the triangle. So it says we have triangle XYZ. So let's draw any right triangle. Okay, so here is our right triangle here. Okay, what are we given? It says that angle Y is 90 degrees. So we know that this right angle here, that is your Y. Then the other two vertices, you can interchange the X and the Z. So it doesn't matter where you put the X, where you put the Z. But it's right here, okay? So you can say Z is here on top and Z is at the bottom. That works as well. Now, what do we know? We know that xy is 7. Here's our xy. It's equal to 7. Yz, here's our yz. It's equal to 24. And then xz is equal to 25. Now we want to find cosine x. So the angle in question here is angle x, this angle. So let's identify the sides if your angle is x. Again, across from the right angle is the hypotenuse. Oh, that means different color. Okay, that's the hypotenuse. Across from x, that's the opposite side. Right next to x is the adjacent side. Okay, we want to find cosine x. Now, cosine, that's our ka, which means we need the a and the h. A is 7 and h is 25. So cosine x is 7 over 25. Okay, let's take a look at number 7. So we have triangle MCT here. So again, we have a right triangle. Here is our right angle. Now, where do we put what letter goes into that right angle? It's right here. T is 90 degrees. So that's our T. And then the other two letters are C and M. Okay, so MC is equal to 85. CT is equal to 84. And TM is equal to 13. Now, our angle here is angle C. Here is our C. So in this triangle, 85 is across from the right angle. That's the hypotenuse. Okay, 13 is across from C. That's the opposite side. And right next to C is 84, which is our adjacent side. So we want to find sine C. So we use the acronym SOH, S-O-H, okay, because we want the sine. So for this one, we want the O, which is 13, over the H, which is 85. Okay. Now, lastly, let's take a look at this error analysis here. A teacher asked the class if they can express the sine A in triangle 1 and sine B in triangle 2. So in triangle 1, Joey says sine A is 4 over 5 and sine B does not exist. Okay. However, Jenny says, sine, I agree with you, sine A is 4 over 5, but in the second triangle, sine B is 2 over 4.6. So who is correct? Now, if you say Jose is correct, then you are right. Okay. Sine A, uh, sine A is indeed 4 over 5 because that's the opposite side and that's the hypotenuse. Okay, so sine is O over H. But triangle 2 is not a right triangle. So we cannot use SOHCAHTOA in triangle 2. Remember, um, the trigonometric ratios that we have used is only applicable to right triangle. So we say here Jose is correct. Sine B does not exist because triangle 2 is not a right triangle.